Hello viewers, this is Peter Ikaja going to take you through direct and inverse proportions, and this is specifically for the O-level mathematics students. Now we shall begin by defining what a direct proportion and an inverse proportion is. And in this case we shall say that a direct proportion is a relationship between two variables when their ratio is a constant value. Now mathematically, if a variable y is directly proportional to a variable x, we write the relation as y proportional to x. Now this is what we call a proportionality symbol. And in math, we shall always try so hard to remove the proportionality symbol by simply introducing what we call the proportionality constant k. So when you do that, then you will have defined the relationship between y and x since they are directly proportional to each other. Then we should also know what an inverse proportion is, and in this case we shall say it is simply a relationship between two variables in which their product is constant. What do we mean mathematically in this case? So mathematically, if a variable y is inversely proportional to a variable x, we write the relation as y proportional to 1 over x. Now again, we are simply going to remove the proportionality sign by introducing the proportionality constant. So when you introduce k, you multiply it by 1 over x, you get k out of x. And so this defines an inverse proportion between y and x. Let's look at a few examples. Example number 1. If m is directly proportional to the square of n and n is equals to 2 when m is equals to 1, find the value of m when n is equals to negative 5. Now, the mere fact that they have talked about a direct proportion in this case, we shall consider our case 1 in the introduction. So in our solution, we shall simply say m is directly proportional to n squared because they said square of n. Then when you remove the proportionality symbol, you introduce the proportionality constant, So we're going to have m is equals to k n squared. Now remember they gave us the conditions. They said if n is 2, then m is automatically 1. So we substitute for n as 2 and for m as 1. That will be the next step. Now when you do so, we shall be able to get the value of k. Because now we have 4k is equals to 1. If you divide through by 4, you will get k as a quarter. Now after getting the value of k, we simply come back and substitute it here. So we now know our proportionality constant. Then we follow the other conditions. So our expression now becomes m is equals to a quarter n squared. Then they also told us to find the value of m when n is equals to negative 5. Now the expression relating m and n is already here, very clear. So we simply substitute for n as negative 5, but we square it. So by substitution, m will be a quarter into negative 5 squared, which gives us 25 out of 4. And if you press your calculator, it gives you 6.25. So we can simply conclude and say, when n is equals to negative 5 like they had said, the value of m will be 6.25. That is our example number 1. Let's look at example number 2. Given that y is directly proportional to x cubed and that y is 250 when x is equals to 10, find the equation connecting x and y. Hence, find the value of y when x is equals to 4. Now, this is still a direct proportion because they mentioned the word directly proportional. So we shall simply say that we are told y is directly proportional to x cubed. We introduce the proportionality constant by saying y is equals to k x cubed. Then we simply substitute for the given conditions. Remember they told you y is 250 when x is equals to 10. So those are the first conditions we are going to substitute. So when you substitute for y as 250 and x as 10, we shall come up with 250 is equals to 1000k. And in this case, if you want to get the value of k, you simply divide through by 1000. And that gives us 250 out of 1000, which simplifies to 1 out of 4. Then after getting the value of k, we simply substitute it back to our expression that we started with. So when you substitute it, you will get y is equals to a quarter x cubed. Now the question said we find the equation relating x and y. Now this is the equation that relates x and y. That answers part of the question. Then they also continued and told us to find the value of y when x is equals to 4. So in this case, we simply substitute for x as 4. Then we shall be able to get the value of y using the same equation. So when you substitute for x as 4, you will get y equals to a quarter into 4 cubed, which is 64 out of 4. And when you divide 64 by 4, you come up with 16. So what we do, we conclude and say, when x equals to 4, y is indeed 16. Let's move on to question 3. It says, given that y varies as a cube of x and y, as a cube of x. Now, take note of the language. They are saying y varies as a cube. However much they have not mentioned the word directly. As long as they have not mentioned the word directly, but they have said a variable varies as another variable, then it is automatically a direct proportion. So it means y is directly proportional to the cube of x. And they gave us y as 8 when x is 4. And they're telling us to find the value of x when y is equals to 1. Let's look at the solution for this. So in our solution, we follow what the question said. So y is directly proportional to the cube of x is as good as writing y directly proportional to x cubed. Then from there, we introduce the proportionality constant. Next step is simply substituting the given conditions. They gave us y as 8 when x is equals to 4. So when you substitute for y as 8 and x as 4, you come up with this step that we have here. Then to get the value of k, we simply get 4 cubed, which is 64, multiplied by k is equals to 8. Then we divide through by 64. If you divide through by 64, you'll get 8 out of 64, which reduces to 1 out of 8. Then from that point, we go back and write the original expression. Our equation relating y and x will be y is equals to kx cubed. But remember, we got k as 1 over 8. That is why you see this equation here. Then the next will be answering the question that was asked. They gave us the value of y as 1. And they didn't give us the value of x. How do we get x? Simply substitute for y as 1, then make sure you look for the value of x because it will be the only variable remaining. So when you put 1 for y, you shall have 1 is equals to 1 over 8x cubed. Then by cross multiplication, 1 will be multiplied by 8, giving us x cubed. So if x cubed is equals to 8 and we want to get the value of x, we simply take a cube root on both sides. When you take a cube root on x cubed, you'll get x. When you take a cube root on 8 of 8, you will get 2. And that means our value of x is 2. So conclusion is when y is equals to 1, x is indeed 2. And that gives us the solution for that specific question. Now let's move on to question 4. Let's move on to question 4. So question 4 says, given that v is inversely proportional to t squared and v equals to 25 when t is equals to 2, find the value of v when t equals to 5. Now, this is now a different case. They have made it very clear that v is inversely proportional to t squared. What does it mean to us? So we are going to say v is proportional to 1 out of t squared because they said inversely proportional. You take the reciprocal of that variable. So when you do that, you simply remove the proportionality sign and introduce the proportionality symbol, which is k in this case. Then the first two conditions they gave us was v as 25 when t equals to 2. So when you substitute the two conditions, v as 25 and t as 2, we shall come up with this step here. 25 is equals to k out of 2 squared. But remember, 2 squared is 4. So when you now cross multiply, the value of k will be as good as 25 by 4, which gives us 100. Now after getting the value of k, we simply again substitute it here. So it means v is now going to be 100 out of t squared. So that becomes our next statement, and this is the equation relating v and t in this case. So from there we can now answer the question. They told us to find v when t equals to 5. So if v is not known and we know the value of t as 5, we simply substitute for t as 5. And when you do so, you will have 100, which is this, divided by 5 but squared, which gives us 100 out of 25, and that gives us 4. So we can now conclude that our value for v is 4, especially when t is equals to 5. So that is our conclusion. Question 5. Question 5 says, in the table below, y is known to be inversely proportional. So it is in the table below, y is known to be inversely proportional to x. So they've given us a row containing values of y and a row containing values of x. So we can see y is p when x is 5, y is 45 when x is equals to 8, and y is 12 when x is equals to q. Find the values of p and q. This is a very interesting question. Now, what is very important is to first note the relationship or the relation. In this case, it is an inverse proportion because they are saying y is inversely proportional to x. So that is what is going to help us. Then when you look at this table, you have to first strictly look at that the column in this case, which contains both values of x and y. Now in this case, we don't know the value of p, so we shall first keep it for the future use. And in this case, we don't have the value of q. We shall also keep it for the future use. Then in this case, we have 45 and 8. So these two values will help us to get what we call the proportionality constant. So in our solution, we follow the language of the question. So we are saying y is proportional to 1 out of x because they said an inverse proportion. Introduce a proportionality constant. We shall have y is equals to k out of x. The next step to that is simply taking the two known conditions. We're taking condition when y is equals to 45 and x is equals to 8, as we can see this and this. So this will help us get the value of k. I've simply substituted for y as 45 and x as 8. Then by cross multiplication, k will be 45 times 8, which gives us 360. Then from that point, now we have our equation relating y and x, which is given by y is equals to 360 out of x. Then for us to get the value of p in q, now in this case, I'm going to begin with p. I simply substitute for y as p as I substitute for x as 5. That will give me the value of p. So when y equals to p, x is equals to 5. So where there is y, I have put p, and where there is x, I have put 5 in our above equation that we have just looked at. And when you compute 360 divided by 5, it will give you 72. So from this point, we also do the same for q. But remember, x is q when y is 12 from our table. So we again substitute in the same equation, and that gives us 12 is equals to 360 out of q. Cross multiplying gives us 12 of q is equals to 360. And if you divide through by 12, it will be 360 divided by 12, which gives us 30. So we can conclude that actually the value of p is 72 and the value of q is 30. Now with all these 5 comprehensive examples, I believe you're now good enough to go in for this exercise. So I'm going to give like 5 questions for you to try out and perfect on this. So these are our questions. That is question 2, question 3 also comes there. Question 4 comes there, and finally question 5 comes there. Now, from this point, I would like to say thank you for being the best viewers and have the best of your time.